This is the second half of the second review test, the one we took on Friday. This part is going to have no calculator involved. So our first question, we're given a graph here. We're told that this graph is called f, and we're first asked for the domain and the range of f. We know that the domain is for x, the range is for y, and we want to know the values that x will go between. Looking at the graph, we can see the leftmost point is at -9, so we can fill that in, -9, and it actually gets there, so we say is equal to. And the graph continues on to the right, and there's an arrow, so it keeps going on without end. So we say it continues to infinity. The range, we're looking at the y values, and we can see that the lowest y value is -6, and it does actually get there, so we put an equals to sign underneath the inequality, and we want to know how far it continues on up. Well, it definitely continues on up to 9, but there's also this arrow, so it continues on and on to infinity. And we say to infinity there. Graphing the inverse of any function means we're going to look for a certain kind of symmetry. And it's a symmetry in which the domain and range, the inputs and outputs, switch places. These graphs and functions are inverses. They're opposites of each other. So what we're looking for is we're looking to take every point, for example, this point here, which is at -9, 9, and plot its inverse, which involves taking the x and the y coordinates and switching them. So we should have a point at 9, -9. We go to our second point that is clearly shown here, which is at -4, -6, and I want to plot a point at -6, -4. And those 2 points were connected on the original graph, so they'll be connected on the inverse graph. There's no clear point shown at the end here, so we're going to pick one. It doesn't matter which one. Let's say we pick this point here, which is at 5, 3, and plot a point at 3, 5. Connect the line, and it goes on forever. And that's your inverse graph. X and y switch places. If x and y switch places, the same thing is true in the domain and the range. So the values that we had in the domain of the original function, -9 to infinity, are now the range of our new function. The values in the range of the original function, -6 to infinity, are the domain of our new function, the inverse. You can check that out on the graph as well. The domain goes from -6 here to infinity, because of the arrow. And the lowest point on the range is -9, and it continues up forever to infinity. Question 2, we're looking to make a sketch. This is an odd, because there's a 3, radical. So we're looking for this shape that has been shifted right 2 and down 3. And that's where the middle of our graph needs to go. Excuse me. The middle of our graph needs to go there, so let's grab it and put it in its place, and that's our graph. And I want to know which one is the inverse. Remember, we said the inverse is going to take a point on the graph, like 2, -3, and flip it. So there should be a point that's at -3, 2. -3, 2 is here. That one doesn't work. -3, 2 could be there. This one might work. -3, 2 could be there. That one might work. -3, 2 could be there. That one will not work. And I want to think about what would happen with the shape. Well, an inverse, aside from the x and y switching places, was also a function that undoes a function. So I want to think about what would undo a cube root. Well, we've seen a lot of this. We've seen if you take a square root of x and you want to make it go away, you could square it. So a cube root of x, to undo that, we would cube it. So the inverse, as we get down to part C as well, is going to be something cubed. Between our two choices here and here, this one, the shape is still a radical, but this one is an odd power. So I would pick that graph. To write an inverse function, this is part C, to write the inverse function, we want to think about what steps did we take in the original function. So our original function has 3 steps. There's a subtraction of 2, a subtraction of 3, and a cube. Or sorry, excuse me, a cube root. So to get the inverse, I want to take those steps in their order and reverse them. So here, if you plug in a number for x, the first thing you do is subtract 2. The second thing you would do is a cube root, and the third thing we would do is subtract 3. The inverse is going to take those steps, do the opposite and the opposite order. So 1, add 3, 2, cube it, and 3, add 2. So step 1, add 3. Step 2, cube it. Step 3, add 2, and that is our inverse function for x. Question 3, very similar to the last question we just looked at. We have a function. I want to do the inverse, which means list out my steps. So here in the function, you plug in a number for x, you multiply by 3, you add 12. The inverse, I would subtract 12 and then divide by 3. So f inverse of x, I'm going to take x, subtract 12, and then divide by 3. We've also seen another way to approach this type of problem. If you take your function, which is equal to 3x plus 12, and you swap inputs and outputs, just like on the graph, switch x and y. So I have x equals 3 times f of x plus 12. And I want to get f of x equals, so you can subtract 12, x minus 12 equals 3, f of x, divide by 3, divide by 3. Whatever we get from this is our inverse function, which is x minus 12 over 3. And you can notice that the answer here are the same. It's up to you how you would like to approach a problem such as this. The last question here, we've got a parent function, and we're going to perform some transformations. Our first one says to shift right 3 and up 5. So I'm going to look at each point, go right 1, 2, 3, and up 1, 2, 3, 4, 5. Move right 3. That was 4. This is one of those places where it's easy to make a small mistake. Right 3, up 5. Right 3, up 5. Right 3, up 5. Connect the dots, and that is our answer for part A. Part B, there's no left and right shift, there's no up and down shift, there's just a stretch by a half. And specifically, we're going to stretch our y values because it's on the outside of the function. It's affecting the output. So I'm going to take my y values, -8, and take half of them, -4. -2, take half of it, -1. 5, take half of it, 2.5. 3, take half of it, 1.5. Connect the dots, and you can see that we've stretched the graph by a half. Another word we see instead of stretch is to compress, right? As if you're stepping and pushing the graph to be shorter. Part C, we're given that there is a negative in front. A negative in front is a reflection, and it's a reflection of the y values over the x-axis. So we take our y values, -8, flip them, +8. -2, flip it, 2, -5, +5, +3, -3. And when you connect the dots, you can see what our graph has done is that it is flipped over the x-axis. Our last graph, we're asked to find the inverse of f of x, which is this notation. And we said earlier in the test that the inverse, you want to take your coordinates for x and y and swap them. So I want to look at my coordinate here, which is at -7, -8, and I should have a point at -8, -7. I have a point here at -3, -2, so I'll have a point at -2, -3. And I would recommend that as you're going along, you connect your dots. This point here is at 0 over, -5 down, so I have a -5 over, 0 down. Connect your dots. And our last point here is at 8, 3, so we have a point at 3, 8. Connect our dots, and that is a picture of the inverse. All right. Feel free to go back through the video and also look at the solutions that are written up as a PDF if you'd like to have a complete version.